Go ahead and pause the video and try these couple warm-up problems. All right, writing an equation given the information, you should have come up with y equals 2 times the cosine of 1/2 x minus pi over 2 minus 1. So don't forget your phase shift. You have to think of it as c divided by b. Don't just think of the phase shift as c. So be very careful there. Notice that in problem number 2, to write an equation, right now, based off of where those 5 critical points are, because I indicated this point up here as my first critical point, so there's 1, 2, 3, 4, 5, that gave me then a cosine graph. So that's why if there's no phase shifts, I knew I needed to start on that the y axis. And so that's why I started at that 0.04. So that's why y equals 4 times the cosine of 1/3 x became my final answer for that picture. All right, today we are going to focus on section 5-6, other trig functions, the graphs of them. Today we're going to be specifically looking at secant graphs and different varieties. So the graph of y equals the secant of x. Secant of x is the reciprocal of cosine. So that means that it has the characteristics of cosine. So we're going to have a period of 2 pi. But remember, because it is a reciprocal, meaning that you have cosine in the denominator of that fraction, we never want the denominator to be 0. And so when you're thinking about your basic cosine graph, there's going to be spots along the way where it touches the x-axis if there's no shifts, and that means that it touches 0. So notice that means that we're going to have vertical asymptotes, just like when we did the cosecant graphs. So in this case, those vertical asymptotes are at odd multiples of pi over 2. Once again, that's not something you're going to have memorized because we are going to be focusing on graphing essentially the cosine graph first, and then from that picture, we'll be able to get our true picture. So variations of y equals the secant of x essentially means that because we're thinking about the reciprocal, we can replace secant with cosine, figure out that cosine graph first, and then finish the rest of the problem by drawing in the vertical asymptotes. And once again, we're going to have parabola-looking shapes at the highest and lowest points on that graph. So let's dive into some examples. If I want us to graph 2 periods of y equals 2 times the secant of 2x, we first want to focus on 2 times the cosine of 2x, which means we want to identify A, B, C, and D. Notice that in this case, there are no values for C and D, so they're 0. So we won't have to deal with any type of vertical or phase shift. Our A value is 2. It's in front of the cosine. Our B value is 2. That's connected to the x. So from those values, we know that our amplitude is always the absolute value of A. So absolute value of 2 is 2. The period is going to be 2 pi divided by B. So 2 pi divided by 2 gives us a period of pi. So we want to create our 5 critical points. Remember though, unlike sine, we don't start at 0, 0. Our first critical point is always 0, comma, A. And so for us, our A value is 2, so 0, 2. Since the period is pi, we want to break it up into fourths. So a fourth of pi would be pi over 4. That's where we're at 0. Then we want to do half of the period. So that means it's pi over 2. And then I want the opposite of A. Then I want 3/4 of the period, so 3 pi over 4. We'd be back at 0. Then I want the full period, which is pi, and we're at A again. Because there's no value for C or D, once again, there's no vertical or phase shift, so I'm going to be able to plot those points. So let me label my x and y axis first. So I'm going to go up and down on the y-axis by ones. Then I'm going to go over and I'm going to do, we want 2 periods. I'm going to do every 2 represents pi over 4. Okay, so this is pi over 4. This is 2 pi over 4, 3 pi over 4, 4 pi over 4. That's 1 period. But then I want to do a second period. So then we're going to have 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Okay, and it could be the same thing if we go negative. All right, so now that I've labeled both the x and the y-axis, I'm going to plot those critical points for cosine. So 0, 2, pi over 4, 0, pi over 2, negative 2, 3 pi over 4, 0, pi, we're at 2. But once again, that is not going to actually be our graph because this is the cosine graph. I'm going to have to do a second period. So I'm back at 0 at 5 pi over 4. We're at negative 2 at 3 pi over 2. And then 0, 4, 7 pi over 4. And back up at 2 at 2 pi. All right. So I wanted this outline so then I can actually graph my true picture. So anywhere that I see that middle point, because it's not the highest or the lowest, that means that that turns into my vertical asymptote. So at pi over 4, we're going to have a vertical asymptote. At 3 pi over 4, at 5 pi over 4, 7 pi over 4. All right. And then I'm going to be putting my parabola at the highest and the lowest point. So notice that there's half of a parabola heading towards that 4 pi over 4. Here, oops, make sure it connects that point. There is the bottom one. Here is another top, another bottom, and then half of another top. Okay, you can leave it like this. If you wanted to, you could have technically known that on like the left side at negative pi over 4, you'd have a vertical asymptote. So technically you could complete that parabola there. You could have done it on the other side. This is technically 9 pi over 4. There would have been a vertical asymptote. So you could have completed it over there. Okay, but once again, 2 periods means that I need to have 2 parabolas going up and 2 going down. And there's my picture. Let's take a look at this problem. We have y equals secant of 2x plus pi over 2 minus 1. So I'm going to rewrite this as a cosine graph first. Identify all the key components. Sketch that cosine graph and then turn it into a secant graph. So we're going to identify A, B, C, and D. A value is 1, B is 2. Remember, C is the opposite, so negative pi over 2. And then D we keep the same, so negative 1. So our amplitude is the absolute value of 1, so 1. Our period is going to be 2 pi divided by 2. So once again, another period of pi. We are going to have a phase shift because we have C. Remember, it's C divided by B. So negative pi over 2 divided by 2 means we want negative pi over 2 times that reciprocal, so 1/2. So negative pi over 4 is that phase shift. We will have a vertical shift because it's the value for D, so negative 1. Okay, so now that we have that information, we can do our 5 critical points. Remember, we'll start with our cosine graph. It's always 0, comma, a. Then we want a fourth of the period, 0. Then we want, half of the period. And then the opposite of a, we want 3/4 of the period back at 0. And then we want the full period back at a. Okay, but those are not the points that we plot because we have some shifting. We have vertical and phase shift. So the phase shift deals with the x. So our phase shift is negative pi over 4. And then our vertical shift deals with the y. That's negative 1. So 0, 1, I want to subtract pi over 4 and 1 from those values. So we'll have negative pi over 4, 0 as the first point. In the second ordered pair, we'll subtract to get 0, negative 1. Pi over 2 minus pi over 4 is going to give me pi over 4. Negative 1 minus 1 is negative 2. 3 pi over 4 minus pi over 4 is 2 pi over 4, which is technically pi over 2. 0 minus 1 is negative 1. Pi, think of it as 4 pi over 4. When you subtract pi over 4, it takes you to 3 pi over 4. And 1 minus 1 is 0. Okay, so that means that these are the points that I actually want to plot to form my cosine graph. So let's label the axes. Go up and down on the y by 1s. Okay, then we have our x-axis. So we're going up and down by pi over 4. Okay, so pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Or we could do a negative pi over 4, negative 2 pi over 4, negative 3 pi over 4. Okay, so all of that takes care of labeling. So let's go ahead and plot our points. So negative pi over 4, 0. 0, negative 1. Pi over 4, negative 2. Pi over 2, negative 1. 3 pi over 4, 0. So that's one period. So now I'm going to do second period. So at pi, I'm back at negative 1. 5 pi over 4, I'd be at negative 2. 3 pi over 2, I'm going to be at negative 1. 7 pi over 2, I'm going to be at 0. Okay, so remember, I am not actually connecting the points completely. I just want this outline for the cosine. So remember, the highest and the lowest points are going to contain those parabola-looking shapes. It's the points that are in the middle. So technically for us, that would be at negative 1. That's where our vertical asymptotes are going to be. So vertical asymptote at 0, at pi over 2, at pi, at 3 pi over 2. Technically, it would be at negative pi over 2. Okay, so there are my vertical asymptotes. So notice that negative pi over 4 is the point that's at its highest, so parabola going up. Pi over 4 is the point at its lowest, so going down. 3 pi over 4 is the point at its highest. 5 pi over 4 is point at its lowest. So there is 2 periods because I have 2 facing up and 2 facing down. And that is my graph. Okay, so that's us understanding and doing different types of variations of the secant graph.